Thank you for the introduction, Jordan. I'm John Ferris, Head of Flexibility at LCP Delta, and I'm going to be picking up on a number of the themes that were explored in the last presentation, not least the issue that Lawrence highlighted around the challenges of the grid connection queue and the time to get new assets connected, and the huge opportunity that buildings that already exist have. They have connection capacity. With energy efficiency, some of that capacity is going unused. And as Lawrence highlighted, a lot of buildings have connected with capacity that they never needed. So there's a lot of opportunity to make use of connection capacity that's already there. However, I'm going to start by answering the question of whether we're in an energy transition, as Lawrence described it, or if this is really a revolution. Most presentations that ask this question do show a typical grid diagram where you've got generation at the top that flows into transmission through the distribution grid and then reaches consumers. That's contrasted with a view of the future where you have generation connecting at every level, from solar panels on a home to wind farms on the distribution grid, and power flowing up and down the grid at every level. That sort of tells us technically what's changing, but doesn't really tell us a lot about what it means for consumers. And yet we've lived through a parallel revolution that might give us some clues as to what might happen. And that's the telecoms revolution, where we've gone through a process of digitization of manual switchboards that needed humans to complete a physical circuit connecting one phone to another. And we went from manual switchboards to dial-up internet. And for those of you that remember the classic 1983 film War Games with the young Matthew Broderick, he used a rotary phone sitting the handset on a modem to transmit data over the phone lines. And this was the early part of the telecoms revolution. And we've reached the stage now where we can not only stream that film into the palm of our hand while we're sitting in a park, but we also have consumers making videos and uploading them onto the internet for other consumers to enjoy. And that's a huge transformation that's happened in the last 20 to 30 years. We've gone from manual switchboards to dial-up internet to mobile broadband. And behind the scenes, we're making much better use of networks that already exist through the digitization and packetization of content. We no longer pay for the use. We don't pay per minute. We don't pay per unit. We have a subscription where we pay for capacity. And again, Lawrence highlighted the need to think about energy as capacity rather than just cost. And we've also moved from consumers to prosumers, or to put it a different way, content creators in the language of the internet. The energy transition at the moment is still in that dial-up phase. So what does this mean for commercial buildings in the energy revolution? Well, commercial buildings are still responsible for 30% of energy-related emissions. Many of those emissions come not from the embodied carbon in the building itself, but from the operations, from what goes on within those buildings. And commercial buildings differ from industrial buildings, which have long participated in flexibility services for the energy markets. So how does what go on inside a commercial building differ from industrial? Well, to start with, commercial load is typically driven by the occupancy. The key building services are to maintain space heating, comfort for the employees and consumers, providing hot water, lighting, and cooling and ventilation. A lot of the process and functional equipment is secondary, as well as supported by ancillary systems that also support the business. In contrast, industrial loads are really driven by processes, motors, compressed air, high process heat, and with data centers, the computing load. There's also an opportunity for on-site generation and storage that Lawrence also mentioned, particularly in the commercial sector for PV on the roof, for container battery in the car park, often replacing backup generators from diesel or combined heat and power plants that provide both heating and backup power. And for commercial buildings, this mix of use and assets leads us to a range of common archetypes. Four of them I'll highlight here. And the first is baseload, reasonably flat, predictable 24/7 consumption that's managed using the assets and backup power or modulating non-critical loads. And this has emerged because for decades we've been told, we've been incentivized to provide flat, predictable power consumption. That has been the cheapest way of consuming energy in a grid where flexibility comes from the generation side, where large thermal power plants are providing the generation from the transmission grid. That's now changing, but it's also unrealistic for a lot of businesses to manage perfectly flat consumption. Where there's a process load, it's typically driven by batch, by when consumers come in for catering, for restaurants and cafes, driven by lunch times, by breakfast and evening meals, by the time that consumers want to consume, not by when the business or when the energy system would prefer that it took place. That load is often driven by thermal needs on colder days, for seasonal needs. There's a need for heating. On warmer days, air conditioning is growing in use. We've just come through a heat wave. There's another one coming next week. Demand from the commercial sector is going to reflect the change in the underlying weather conditions. And finally, compared to industrials, a lot of demand is smaller than the markets would like. And the assets need to be aggregated to provide flexibility at a scale that the markets will contract with. And so what does that look like for a number of typical types of business? Because commercial buildings do differ both across the sectors and within the sectors. Lawrence highlighted the opportunity for warehouses, who are perhaps facing the biggest change of all the sectors. The growth of next day delivery is increasing the demand for warehousing. The opportunity for solar generation on the roof can reduce that peak in demand through the middle of the day. And the opportunities for fleet charging as we electrify delivery means that vans and lorries may need to charge while they're being loaded and unloaded at the warehouses. And this all creates an opportunity for a combined transformation where solar and batteries and EV charging are added to the traditional use of electricity on these sites. Based on data from the Carbon Trust, the typical breakdown of energy is really driven, or historically has been driven, by lighting and space heating. If you have a refrigerated site, that's driven by the need for refrigeration and the increased load in the summer. That pattern could change significantly as we electrify electrify the fleets for delivery and combine that on the site. The retail environment does need to prioritize client comfort, particularly within store hours that historically were the higher price periods. Now we see lower prices at lunchtime, but still with an opportunity for preheating in the early morning before demand picks up. Maintaining produce at the correct temperature, having resilience and security of supply is important. And the mix of demand is spread across heating, cooling, and lighting across the sector. Demand is driven, particularly seasonally, from demand for heating in winter months. Cooling and refrigeration picks up in the summer months. But holiday periods and weather also affect the customer traffic and drives demand on the sites. Finally, hospitality. The primary need here is maintaining client comfort. Heating, particularly in hotels, has constant demand for hot water, whether it's in the bedrooms, kitchens, or for cleaning, or for the leisure facilities. That catering does bring demand from refrigeration as a base load, but also heightened demand around mealtimes. And the sites can range from small cafes to the very large hotels with diverse energy consumption and operational profiles. But a key load from hot water and space heating, which can be optimized based on prices throughout the day and throughout the seasons, and with the assets that are used. So typically the top assets that can be used for flexibility are around preheating and pre-cooling, storing hot water in advance. And also there are opportunities for using batteries to manage demand. So if loads are typically driven by the needs of customers, how can those loads be turned into flexibility assets, delivering benefit and getting value from the system? We have to ask what is it that makes an asset flexible? And in contrast to merchant batteries and generation that exist purely to provide services to the grid, to provide generation and flexibility, what makes an asset flexible in a commercial environment is the ability to deviate from the usual schedule and load patterns to provide value, but without disrupting operations, which is their primary use. Within that, the different services that can be provided depend on how fast the asset can respond. As we have less large thermal generators on the system, the need for faster acting flexibility is required. Certain assets can respond quickly, others take time to respond. In the commercial sector, advance notice might be required, whether it's days or hours, to initiate the response and change the profile. Some services, such as frequency response, only need a very short generation. But if we're helping the grid to recover from the failure of a power station or an interconnector, a longer duration of response needs to be sustained. And the frequency of response can be constrained both by operational or technical capabilities or the warranties on an asset. That frequent cycling of batteries or other assets can cause it to degrade more quickly and become less reliable over time. That's a cost to the business of providing the services that needs to be considered. Lawrence talked about growing constraints on the grid, and these are emerging in different areas at different times. So an asset in a part of the grid that is constrained can derive value from the growing local markets and the local flexibility needs. We do see them expanding over time, and the use of markets by DSOs to manage their grids has been growing and will continue. At the moment, that's still an opportunity that's driven by the location of the asset. So all of these directly determine an asset's capability of participating in the value streams. The size of the asset can affect how the assets participate, and smaller assets will need to aggregate to reach the thresholds that the markets require. And those markets can range from ancillary services that are operated by NESO, the typical frequency response, and and markets to manage frequency on the grid and recovery from the failures of generators and interconnectors. The capacity market is also open to demand-side assets that give guaranteed payments over the longer term for assets that can be available during capacity market events where the system struggles to meet demand at peak times. But we're seeing a change in the rhythms of the market where price fluctuations throughout the day are becoming much more volatile, whether it's the drop in prices around lunchtimes when solar energy is abundant, or when wind picks up, typically overnight and in the winter, or periods where prices spike, where renewable generation are low and traditional generation is unavailable. So there's an ongoing opportunity both to trade in the energy market that's been introduced in the UK through grid reforms known as P415 that allow demand-side assets to actively trade in the wholesale market, as well as opportunities to optimize against tariffs where those different prices and different time periods are set at the day-ahead timescale and gives businesses time to shift their energy use to the periods where electricity prices are lowest. Typically, this is seen in smart charging of EVs, but it can also be visible in preheating and pre-cooling, using assets when prices are cheaper rather than when at the point of need. But within the site, commercial buildings also have an opportunity to derive value that don't rely on the markets. Typically, that's around managing your peak capacity, reducing thresholds to save costs, or optimizing around the dynamic network charging. But also for those sites that have generation on site, maximizing the use on site is often the best way of managing costs and both reducing their costs and decarbonizing their consumption. And assets like batteries and combined heat and power also provide resilience to sites and can maintain essential services during a grid outage. So think about how energy is generated as well as consumed on site provides benefits that aren't necessarily captured by the market values. In order to do this, it does complicate what happens on the site. You need to be able to connect to the assets, to monitor and control them in order to respond to the different needs of the markets. They may need to be aggregated both within the site to coordinate aggregate demand, but also with other assets to be able to trade in the markets. Optimization being having the capability to forecast demand, to forecast load, optimize use for the site, as well as optimizing for the markets where prices change throughout the day, are both activities that are becoming increasingly important and rely on that good quality data that we talked about in the last presentation. And the interface with the value streams, being able to determine which markets to bid into, trading needs a connection to the markets to send the bids and to receive dispatch instructions, are all parts of the activity that are required in order to monetize distributed assets in the markets. Now, in order to support commercial businesses whose primary function is clearly not market trading, there's an ecosystem of companies that have emerged, some of which specialize in connecting to different types of assets, whether it's heat pumps or EVs. Others focus on coordinating across the whole site through an energy management system. Some may focus on smaller sites and smaller businesses or residential customers. At the other extreme, some do focus on grid-scale assets and the large batteries. But within the commercial sector, a lot of businesses are delivering services both to optimize assets, to optimize financially, through the provision of forecasting and optimization services. Some even provide market access, including taking the role of the retailer and providing bespoke tariffs that really maximize the benefit from the assets and the flexibility that they can provide. You don't have to have a flat tariff that charges the same amount for consumption throughout the day, throughout the year. The tariff can both reflect the cost of electricity on the markets, but also incentivize and reward shifting consumption to the lower price periods. And to wrap up, I just want to highlight three examples that show both the opportunities that commercial buildings have in the energy sector, but they also highlight some of the challenges that we've seen and continue to see. First, from the UK, is of a cold storage site that's been delivering flexibility for over a decade. And it's provided nearly a megawatt of flexible capacity in markets such as store, the innovation project Quick Turn, and the capacity market. In that time, the markets have changed enormously. The number and the range of markets has evolved. We now have the dynamic suite, demand flexibility service. Store's been replaced by quick reserve. Quick Turn was an innovation project. We've had other innovation projects. So understanding the market structure, understanding where value can be provided, is something that has evolved over time. And not all the markets do allow access to commercial buildings, to commercial assets. The UK market is one of the most advanced in enabling access on paper to the markets. But in practice, there are still a lot of challenges in participating in markets that are structured for large grid scale assets, whether it's the metering requirements, the size of bids and capacity that's required. Access to enduring markets on a level playing field for demand-side assets still remains a challenge. Now, one way that challenge has been addressed comes from an example in France, where there are grid stress signals that are sent to consumers, enabling commercial buildings like shopping centres to use both the HVAC and, to some extent, lighting and other energy management to reduce peak demand of up to 64% during the alerts. But that's not a business model that's replicable across Europe. And for businesses trying to change their operations, being able to replicate them across the continent is going to deliver much more value than one where a different approach has to be taken country by country. And finally, the example from Finland, where Lidl is integrating over 100 supermarkets into a trading unit that can provide flexibility to the reserve markets, largely through battery and the extensive cold storage operations in the large distribution centre. The challenge here is multi-asset interoperability. We still lack standards for communicating and control and coordinating across multiple assets, whether it's e-boilers, small-scale BESS, even rooftop solar providing flexibility services. So the opportunities for commercial buildings providing value to the system do exist. provides value to the building owners, reduces the costs. But there's still a number of challenges that do need to be addressed if we're going to maximise the opportunity.
Thank you. I was just making sure that you had nothing left to say. I do appreciate that, John, especially at the end there, where you highlighted sort of the differences between, what other countries in Europe are doing versus here in the UK. Where do you think we could learn the most as the UK to sort of you picked out France and Finland there. Do you think there are other markets where, perhaps they're doing it even better and we can learn even more?
So I think one thing that's continuously surprised me, particularly over the last couple of years, as we've heard more and more about the prevalence of negative prices, especially
Mm,
driven by solar. And when we think of maybe the southern latitude that countries, though we think that might be coming from the very sunny countries like Italy and Spain, whereas we're actually seeing them in countries like Belgium and the Netherlands that I don't think are any sunnier than the UK.
the UK, yeah.
And it feels to me that the opportunity for commercial buildings to really harness the benefits of solar, to install on-site PV on the rooftops, on warehouses, has really been grasped much more openly in those countries. And obviously, the first benefit is on the site itself.
Mm,
That's now driving the opportunities for batteries to store that power so that it can be used at the evening peak and reduce both the peak wholesale prices and the red band dual charges, the peak network prices. That's an opportunity that I think UK commercial buildings can catch up on.
yeah.
And that prevalence of negative prices that we're seeing in Northern Europe, in Germany, is an opportunity that those businesses have that we don't see to the same extent in the UK market. So that driver for flexibility is coming a little bit more from the ancillary services markets where commercial buildings are competing with merchant assets, with the big batteries. And it's much
Mm.
more challenging. So that the drivers of value aren't the same as it is in other countries that are perhaps easier to access in those countries.
And you mentioned at the beginning there about solar and how it is one of the easiest solutions that building owners and operators can basically go and install on their roof. Or I know in France and even places like Greece, you increasingly see people install them over car parks, which seems like a no-brainer. If you're a retail store, you have a large car park, therefore you could be generating significant amounts of electricity using solar canopies. And yet we don't see it as widespread here in the UK. I know some people have been calling for legislation like there is in France for larger car parks to have solar carports. What are your thoughts there?
So I think you're right to highlight the legislation makes
Mm,
it a requirement. I think there are a lot of burdens on businesses in the industry. I would rather see it driven by the opportunity, by the value that can bring those site owners. That if you can combine the carports, the solar carports, providing power on site with destination charging at those locations that keeps the consumers there. If it's a retail or a sort of a hospitality, the
mm,
consumer is there essentially to do their shopping, to enjoy
mm,
a meal. That's where the business gets most of its value from. But if they can also provide charging services, the consumer charges from power that's generated on site, it really seems to be a win-win for everyone, with the consumer, the business getting another value stream, and for the grid. So I would rather see the incentives and businesses um, take the opportunities rather than being a legislation that mandates that they install them.
the carrot rather than the stick. Yeah, and obviously solar carports have many benefits, especially with the heat wave that we're due next week. It provides shade. It would be nice to see more in the UK. Maybe even if you did take the legislation route, there could be incentives rather than the stick of
Yeah.
you have to do it like there is in France. All right, that is us out of time for this session. John, really do appreciate you joining us and for all your insights there.
Thank you.